Exothermic and endothermic reactions. Several exothermic and endothermic reactions will now be described. Sodium and water, cesium and water, sodium and chlorine, sodium carbonate and ethanoic acid, photosynthesis, and cellular respiration. Sodium, or Na, is a member of group 1 on the periodic table. It is a soft metal that is very reactive with certain elements. It is normally stored within a jar of mineral oil to prevent it reacting with water or the air. A small piece of sodium metal is dropped into a cup of cold water. The energy released by the reaction ignites the released hydrogen, resulting in sound and a flame. The S here means solid, AQ here means the compound is dissolved in water, and G means gas. All the elements in group 1 react strongly with cold water, producing hydrogen gas and a hydroxide based on the element. OH stands for hydroxide. They are all exothermic reactions as they release thermal energy. The further down on the periodic table, the stronger the reaction. Cesium, or Cs, is the most violent. Here's the equation. Click here to see a video of the reaction. The last element in group 1, francium, is radioactive and very rare, so it has never been tested with water. Only a few milligrams of it can be found at a time. Sodium also reacts with chlorine gas that is very reactive. Chlorine gas corrodes metal and is poisonous to people, animals, and plants. In solid form, it is used to kill germs in swimming pool water. In the presence of light, these two dangerous elements react explosively to form table salt. It is an exothermic reaction. Sodium carbonate is added to ethanoic acid in a beaker. The resulting reaction absorbs thermal energy from the air, and the liquid in the beaker cools down. This is an endothermic reaction. The reaction produces sodium acetate, which is used to replenish electrolytes in a person's bloodstream. Sunlight provides the energy for life on the Earth's surface through photosynthesis. Photosynthesis is an endothermic reaction, as it absorbs thermal energy to form new products from its reactants. Photosynthesis is a sequence of many reactions, but the net equation that summarizes the process is shown in word and equation format. Sunlight provides the thermal energy for the net reaction. So carbon dioxide plus water, and then you add sunlight and you get glucose and oxygen. Photosynthesis captures energy from the non-living world and converts it to chemical energy that cells can use. Photosynthesis captures the free energy of sunlight and stores it in the glucose molecule. The energy stored in the chemical bonds of glucose is then used to power life. Photosynthesis makes much of life possible. The glucose molecule contains more chemical energy than the water and carbon dioxide from which it was formed. When the reaction runs in the opposite direction, energy will be released. Photosynthesis is an endothermic reaction. The reaction in the opposite direction is cellular respiration, an exothermic reaction. Through photosynthesis, plants capture energy from sunlight and transform it into chemical energy stored in glucose molecules. Cellular respiration reacts the glucose molecule with oxygen, releasing energy that is used to power the cells in living organisms, including people, plants, and other animals. The glucose and oxygen molecules, the reactants, are transformed into the products, carbon dioxide and water. Energy flows from sunlight and is converted to chemical energy in the glucose molecule. Cellular respiration transfers the glucose energy into other molecules. These molecules build other molecules or do physical work, like this Venus flytrap shutting on a stick.